Good afternoon. Thank you, sir. Good afternoon, ma'am. Good afternoon, sir. And good afternoon, everybody, my dear friends. Good afternoon, Papa. My thesis topic is Strategies for Energy Efficiency in Technical Educational Institute of Hot and Dry Climatic Zone, India. The sequence of presentation will be introduction, the need of the study, hypothesis, methodology, scope, limitation, study area, data collection, results discussion, future scope of research, bibliography, examination comments. So India is the fourth largest economy of the world in the year 2018, which is around $3 trillion, and with an annual growth rate of 6.8%. India is the third largest primary energy consumer in the world, and its share is increasing. In 2014, India accounts for 17% of the population and contributes 5% of the total CO2 gases emissions. As highlighted in sustainable development, that there are many aspects related to energy that has been established in goal number 7 and goal number 11, and the intention of United Nations Sustainable Development Program is to ensure to protect the planet not only in the social domain but also in the environmental domain.
सुनील, इसको presentation mode में लेके आओ ना.
Yes.
Full screen
कर दीजिए सुनील.
Yes, ma'am. So right from the Earth Summit, 1992, there are several summits and conventions, and they have been happened regarding saving our planet and to reduce the carbon emission. Likewise, in Kyoto Accord, it was a commitment by several countries to reduce greenhouse gas emissions, and subsequently Copenhagen and Rio 2012 and Paris conferences has happened. And this table accounts for the per capita energy consumption in Indian context and its comparison with per capita consumption with OECD countries and the world. So that there is a clear trend that per capita consumption is increasing, although it is very low in compared to the world or the OECD countries. But yes, there is a substantial increase. It is growing from 561 kilowatt hour to 804 kilowatt hour per capita. Likewise, the universities are also increasing. The growth rate of in universities has been phenomenal from 1950 to 2019, and the technical universities has always is also increased 6 times from 25 to 142. Need for the study, almost 80% of the educational institutions and 50% of technical institutions are constructed prior to 2011-12, and 1/3 of these institutes have buildings that are more than 2 decades old. The students' intake is increasing. But the energy conservation building code is not being followed, as it was energy conservation code came into enforcement in 2005 and then revised in 2017. Most of the states are not following it, but traditional wisdom was taken into account, and eminent architects have designed most of the institutes. So they were actually having climate responsive buildings. And since lack of energy metering is there, so that is another, at building level, that is another problem. And then educational buildings are not given due importance in real life scenario as catalyst for sustainable development, which is again and again highlighted by national and international level conferences and declarations. Guan et al. And Chang in 2016, they have highlighted that educational campuses can act as the role model, and they can be acting as catalyst for sustainable development around the surrounding areas. But educational institutions, they are not given the due importance in comparison to other buildings. Energy efficiency for educational campuses located in different climatic zones is again a very essential part, because India is classified into 5 different climatic zones. So it is essential to have segregated but still comprehensive strategies for different climatic zones. The hypothesis of the study is implementation of appropriate architectural design significantly increases the energy efficiency and reduce energy consumption in the technical educational building in hot and dry climatic region. So the research question that I was taking up are the factors which are affecting energy consumption, the characteristics of existing educational buildings, what are the benchmarks related to educational buildings in hot and dry climate, what are the appropriate design measures that can be incorporated for improving energy efficiency. So likewise, the aim was formulated. The aim is to evolve strategies for achieving energy efficiency for technical institutional building located in hot and dry climatic region of India. To fulfill the aim and the research questions, some research objectives were formulated, like to identify the scenario of energy consumption in technical educational buildings in India and specific to hot and dry climatic region, to identify the existing benchmarks and mandatory provisions related to it, to formulate an appropriate methodology for estimating energy consumption of these technical institutions, to assess the energy performance of these institutions, to find out the lacuna performance gap related to energy efficiency, and finally to formulate strategies for improving energy efficiency in technical educational building in hot and dry climatic region. This is the research methodology that has been followed. It is a simultaneous action of literature review and field studies. They are culminating into some actions. So for every literature study that is done, some kind of field study or reconnaissance survey of the areas is done, so as to find out. So this is the broad research methodology that is being able to, through which I was able to culminate my study. The detailed methodology which is developed out of this will be discussed later in the presentation. Scope of the study is analyzing the energy consumption pattern and finding out appropriate architectural and related energy efficiency measure for the reduction in energy consumption. Academic and administrative buildings are taken into account for the study. Methodology for creating building energy models for the technical institutional building and checking up of performance of various energy efficiency measure. These are taken into account. The limitation is related to the data availability and of the energy consumption pattern for separate buildings. The study is limited to walk-through energy audit only of the 3 existing institutes. The factors like exterior lighting, sewage treatment plant, water supply is not not taken into account for implementing energy efficiency measures. And the study is strictly limited to academic and administrative building, or it may be a combination of academic plus administrative. The analysis of energy related issues is strongly related to capabilities of the software used, and in the present research, the visual comfort is not taken into account, and only the thermal comfort is taken into account. Literature review. The literature review is vast literature review is carried out and related to the modeling of energy, modeling building energy and calibrating the models, energy efficiency measure related buildings and educational buildings, consumption pattern in multi-user buildings, role of various building elements, especially related to space type or which can be developed for benchmarks. Various codes and standards are studied, and sustainability declarations, policies, green rating systems, and software tools that are that can be used for simulation are studied in the literature review. This is there are 3-4 important papers that I want to highlight that becomes you can say the backbone of the thesis through which important decisions are taken up. Like from this sustainability analysis, this paper, the various strategies like bottom-up approach or top-down approach or hybrid approach. So an hybrid approach, bottom-up hybrid approach is taken for the study. Then a study conducted in IIT Roorkee by Dr. Sunil Sharma. So that is that have shown that academic buildings can can be shown that they can have a reduction of energy up to 40% even in non-AC buildings. Then this one is an important study done by Abdelelamin, and which shows a calibration model approach, that how can a calibrated model can be achieved through inverse calibration method. Then there are another paper related to the which is treating that instead of having specific APIs for building, the spaces can be taken as, say, if there are 5 buildings, in 5 buildings there may be some common spaces, so that common spaces can be taken up as the internal matchmark for the energy efficiency aspects. So that is again a good outlook. So this is being used in the study also. Then there is walkthrough and audits. So there are a lot of literature, and yes, these are the parameters like courtyard design, then glazing, wall roof, U values, R values, coefficient of performance. So these are the parameters which are taken up by
नहीं काटना नहीं पड़ेगा फोन आप अपने आप ही अगर टाइम के
kindly mute your voice, because there is a disturbance. Kindly please mute your voices. So there is a presentation going on. So literature review. The building energy simulation softwares, there are n number of softwares available, out of which eQUEST, Design Builder, and IDIC are favored by architects. And this is the flow chart that is given by Confederation of Indian Industry. This talks about how you can conduct an energy efficiency in buildings. So there is a flow chart. So there is an established methodology, but this methodology is specific to a single case building. Now, through literature study, there are gaps that have been found out, like Indian university don't have a comprehensive environmental policy. There is no set mechanism to quantify sustainable development in most of the universities. Universities lack mechanism to measure electricity load and in different land uses or different typology of buildings. And photovoltaics is, prior to 2018, most of the universities, specifically in hot and dry climatic region, they are not having solar PV panels. And further, the facade integration, so the building applied photovoltaics, they are also not taken into consideration. And there is a dearth of study pertaining to energy efficiency in hot and dry climate, specifically to the Indian context. And there are some studies, like Sela et al. Has done study related to the hostel blocks of the university. So most of the administrative, or you can say the labs or the academic area, they are generally ignored. Building simulation is not given due importance at the beginning of the energy efficiency work. And although only the detailed energy audits can provide the exact model, but they are also expensive one. And inverse modeling can be used for creating energy model in universities where some metering is not available. No rating till date is highlighting energy efficiency in university building pertaining to India. So these are the gaps. And some likewise from literature, then field surveys. So the surveys are also done in accordance with the literature review. So some of the expert opinions, I found out that what is the problem, that why energy efficiency is not taken into account for specifically the architectural measures. So they say that the lack of procedure for energy efficiency is there. So there is no separate submetering. So most of the people are reluctant to go into the architectural domain of the energy efficiency. Power factor related errors are one of the biggest challenge, because if the power factor is 0.85 or 0.7, then there is no point in creating a energy model, because it will not be within the tolerance limit. And another is that lack of institutional will and the lack of resources are another one of the key points. So likewise, for the objective one, to fulfill the objective one, various parameters identified like EPI and EOI, and so depending upon this, a vast energy consumption scenario of various institutions, they are clubbed together and put it into a chart kind of a thing. But again, various researchers have done, and they have taken different parameters for assessing it. Like for IIT Mumbai, the main concern was energy occupancy index. They were not concerned about the EPI. So EPI in terms of geographical area, this is a new term that I am coined, because EPI build-up, that is approximate, and that so to have some kind of comparison between these institutes, I have to coin this word EPI, geographical area, means energy performance index with respect to the geographical area of the institute. Because for case of IITI Ajmer, and even for Bikaner, I don't have the build-up area, so I have to coin this word. But yes, energy occupancy index was easy to find. So the main, you can say that there is a lot of variation in higher level institute, tier 1 institutes. You have more energy occupancy index as expected, because lot of sophistication equipments are there in these universities, and in IIT Ajmer it is not available at all. For my case studies, yes, RTU quota has almost twice that of energy engineering college Ajmer and engineering college Bikaner. And as far as EPI is considered, again for Bikaner it is just 7. For RTU quota it is 43.8. So there is a lot of variation even within the state universities. This is the comparison with the some of the foreign universities. Then you will find that the Indian universities, specifically in hot and dry climate, they are way below. It's hovering around 40-50%, 40-50 EPI mark. And so it's not ideal to even judge with the other universities which are located in developed nations. So the inference is that most of the tier 1 institutions, they have substantially large consumption and than the 2 and the 3rd level institutions. The EPI in comparison to educational institutions shows that the Indian institution has comparatively less, or you can say very less. Of the study area, the hot and dry climatic region, which constitute around 15% of the area and 10% of the population, here is taken up for the study. And as this definition is taken from SP 41, so the area which is having temperature more than 38 degrees Celsius and relative humidity more than 40% prevail during the hottest month of the year. So these areas are classified into hot and dry, and here you can see the map of India taken from NBC, and this oblique shaded region, this is the hot and dry region, which covers Rajasthan, most of the Rajasthan, Gujarat, Saurashtra, and Vidarbha, and some area that is adjoining to Rajasthan of MP area that is adjoining to Rajasthan, MP, and Maharashtra. For objective 2, to get the energy benchmarks, Bureau of Energy Efficiency code like ECBC is taken up. NBC is studied. Indian model of adaptive thermal comfort was taken up. IEEE standards, GRIHA, IGBC, and EC Act. So this is the EC Act, which provides a legal framework to measure to have energy conservation. Then the ECBC code, again, for Bureau of Energy Efficiency, there is no set guidelines related to EPI of universities or school buildings. Although there is an energy management guidebook, but this is again a guidebook which are providing recommendations related to energy efficiency, but they are not giving some benchmark values. And for commercial buildings, for institutional building, they are saying, but this is again 150, 170. So these are on the very higher side as far as my preliminary finding at that time related to my study area, that was hovering around 30, 20. So again, the EPI is given by Bureau is on the higher side for institutional buildings. Then these are the energy energy efficiency list that Bureau provide related to envelope, lighting. So some of these are discussed, and some of these energy efficiency measures are taken up for the study. For thermal comfort, Indian model of thermal comfort is taken up, developed by the SAP University, and this is an ideal platform to apply it, because most of my buildings are naturally ventilated. So 90% of my building areas are naturally ventilated. So the boundary conditions like 20.5 to 28.5 degrees Celsius is taken up. Similarly, NBC has chapter 11, that is approach to sustainability, which has been taken up for the study. Griha and IGBC, they are the most prevalent rating systems in India. Griha provides benchmark for institutional building in hot and dry, that is 140. That is again on the very higher side for daytime building, and 450 for 24-hour building. So again, it's not ideal to compare ideal to take any of the benchmark. If you take 140 as a benchmark, it means our buildings are super compliance. If you take ECBC, then it will become super compliance, super ECBC compliance, but that is not the actual case. So that is one of the reasons the study is taken up. And these are the ECBC compliance that related to the institutional, to the university school building, related to various components. These are the ECBC compliance benchmarks, ECBC plus and super ECBC. Similarly for skylight, UDI, useful daylight illuminance, and lighting power. So these are listed here. Now the detailed methodology. The detailed methodology is taken up in a phase-wise manner. 7 phases are discussed. The first one is to identify. So all these. So by going through these 7 phases, which is related to the creation of model, then applying model to the simulation, then taking up values and data, and then assessing it and applying EAMs. So by going through it, I find that phase 4, 5, 6 need to be more clarified. The first one is the manual calculation component, and the second one is the integration of manual and simulated component of the building energy consumption model, and the third one was the energy efficiency model. So I will take this phase 4 methodology, where individual buildings are there. In the model of individual buildings are created, and through inverse calibrated method with disaggregation approach, and through this, say initially the architectural data is taken up, then the initial model is created, then occupancy schedules are fine-tuned, and which leads to an occupancy schedule calibrated model, that is termed as 2. Then the LPD, EPD, they are fine-tuned with the help of their schedules, and that becomes the third model. Then HVAC is calibrated. How HVAC is calibrated? Through 2 surveys, the walkthrough energy audits and surveys through this. So initially this is the manual method. Finally, I will come up with the model, that is A, B, and C. These can be n number of buildings. If there are 10 buildings, I can have 10 buildings model. Then I have to take up their cumulative electricity consumption that is coming through the model, and I will have a check with the energy bill of the institute. Since energy bill of the institute is giving up the complete energy bill of the university, so when I am clubbing all these buildings, I can have a test. If there is a uncertainty of more than 5%, then I can again go back to this stage, at the stage number 2, and then I can recalibrate it till I will achieve the desired uncertainty limit of plus minus 5%. Then after achieving it, I will have another check. So this is my intervention in the methodology, that I will take up HVAC load as a variable load, and all the other loads like lighting load or lighting load or other loads which are not climate dependent. So for all the months, the main thing is the HVAC load, that is the varying factor. So that HVAC load, through calculations, it has been calculated month-wise by subtracting the non-variable load from the total electricity load. So if that check is also plus minus 5%, the calibrated model is achieved. If it is not, then again I have to check the schedules of HVAC equipments that are installed in my building. So there is a complete chain, and there are 2 checks involved in this. So this is how the manual model initially was created, so that the data is available for further simulation work. Because in simulation there are a lot of parameters, and these manual computations are necessary to fulfill some of the parameters which are not find through the survey. Now in the phase 5, that is related to converting the manual model into the simulated model. So there is a 3 approach. So that is again the energy efficiency of institutions, as per depending upon the infrastructure available, they can have calculated approach. I have already talked to you about the calculated approach, that is termed as part 2. Part 1 can be used if calculated data is there, and we can have a simulation software. We can transfer the data into the simulation software, and then individual building calibration can be done from calculated model to the simulated model, and cumulative building calibration can be done. So there are two types of calibrations that need to be carried out, so that the calculated and the simulated models are more alike in nature. And the third one is the standard model, which can be created using the standard that are given in ECBC, like everything related to occupancy, or these are predefined. Some standard values are there. So if there is some gap within simulated model or calculated model, if there is a gap, if some parameter is still not identified, so we can take the help of standard model instead of taking any arbitrary value, and then we can find out we can run the energy efficiency parameters on run, and then we can do the analysis, and then finally the database can be generated for the university, which can be the base for the energy policy for that particular institution. So this chart is explained here with more elaborations, with how with calibrations. So these are the steps which are involved. So collection of data, collection of classification of similar spaces, classification of spaces within the building, then different checks are applied. So this is again that zoom of that. So for this, I will just little explain. The first step was the data collection related to architectural data and energy bill and weather data. Then second is to classify the buildings at different levels, maybe campus level, local group level, cluster level, individual building level. Then the third one is to find out EPD, LPD, AC tonnage, occupancy pattern. Some of these can be derived through some calculation, or some of these can be taken up directly from the primary survey data. Then calculation related to energy consumption and EPI of each building is done. Then calibration. The rule is summation of energy consumption of individual buildings should be equal to the energy consumption of the campus derived from the electricity bill data of that university plus minus 5%. So this is the first check. Then model output. We can then from this we can get a lot of output related to EPI values of different levels. Then the seventh step is the output data is available for entire process, can be used for data set for educational buildings. And then eighth one is calibrating of energy. This can also be done if this is again, so there are two checks. The first check is good enough if the more accurate model is not required, but the second check is more important, because then the uncertainty limit is again checked. In this model, in this study, I have done 3 iterations to come up with the desired result. Now the energy efficiency measures that are taken up are the daylight, LPD, fenestration, wall insulation, roof, and shading as far as architecture points is considered. For mechanical, thermostat is taken up, and HVAC. I have gone for 2 type of HVAC system. Either you can go for 8A, or either you can go for 8B. So 8A is high 5-star HVAC system, and 8B is a centralized HVAC system. Then there is solar photovoltaic, and then there is a combination of, the first one is a combination of architectural measures, and another is combination of architectural plus mechanical measures. And this EM list can be more extensive, but it is strictly as per the software that I am using. This is eQUEST software. These are the institutions that I have taken up. This is the criteria through which I have decided which type of what college I have to take up. So finally, 2 institutes are taken up, that is Kota and Ajmer for detailed study. So out of 11 institutions, government institutions, 4 are taken up. Out of these 4, 2 are done for detailed study. This is the more you can say case study map. Here you can find this is Bikaner, this is Ajmer, this is Kota. As far as Köppen classification is considered, this Bikaner, Ajmer, and Kota, they are again, this is the hot and dry climatic region line. So these 3 case studies represents you can say the different areas within that hot and dry classification. Now this is quota. This is 2005. You can see this is the old academic block that is known as UTD, University Teaching Department. There is nothing here. Now here in 2010, the administrative block come up with VC building, registrar office and examination office and sports complex. Then here the computer, in 2016, the computer department come up. And in 2019, there is another petroleum department come up. So this is the master plan. These are the glimpse of the university. I will just highlight that they have these vaulted corridors, double height corridors to connect the old buildings. So the old structure has some kind of architectural motifs. This is again corridors which are connecting different blocks. These are the maps. This is a newly constructed building, computer department. This is Ajmer. Ajmer, you can see there are a number of buildings, civil building and academic and department building, and these four are labs. This is library. Initially in 2007, there was only one building, subsequently in 10. So this is the master plan. Here you can see that courtyard buildings are there. So the academic and the department, two buildings are studied for Ajmer. So they have courtyard type of planning. This is again a very striking feature is the shaded corridor and the western facade. Although the timing of this building is such that this west facade is not able to get any kind of function because the institute get over around 2 p.m. And this is Bikaner that is left out due to some data availability problems. These are the strategies that are architectural strategies, interventions that have taken that has been done in Kota, Ajmer, and then Bikaner. So I will just come to the major findings that all these institutes, they have lacked some metering, they have devoid of long-term energy management plan. Although some renewable energy systems have been installed, which are even they are large in case of RTU Kota, or in case of Bikaner, it is as small as a pilot project. Most of the institutions are devoid of updated data related to the building-wise connected load. So this is one of the major hurdles that I come across. So that is why I need to go to each and every room to do the manual calculations for manual model. Now the lacunas that are found is that no energy efficiency measures applied to the old buildings. Institutional regulatory level regulatory setup for implementing energy efficiency is completely missing, and policy related to architectural interventions are not there. So these are the major lacunas, and this is how I collected the data through field studies for different buildings, various parameters. These are the models that I've created in eQUEST. In all 12 buildings are taken up. Now, after doing this, I have decided the values for the EEMs. That is again important. So I compare with, I compare the buildings of Kota and Ajmer with the ECBC components. That is ECBC compliance, super ECBC, and ECBC plus. And then I have come up with some kind of concrete information like what exact intervention I need to do. In case of LPD, say. I had decided that LPD need to decrease by 40%. So, for an example, say in RTU Kota, any in old buildings like Block A, B, C, D, if they have LPD, we say 5 watt per meter square, and if it is coming close to say ECBC super ECBC compliance, say super ECBC is say 4.2. and my readings are coming 5 watt per meter square. So I will go for super ECBC. It means I am taking up a next higher level. Similarly, for fenestration, I have gone for higher level. For wall and roof, 1 inch, 1.5 and 2 inch. These three are taken care, but since the building envelope was too massy, so 1 inch was taken into consideration, and which was able to cross whatever I have taken up for that. Then HVAC, definitely 3-star units are there, so I have converted into 5-star for 8A. For 8B, eliminating all the split ACs, I have taken up a VAV air conditioning centralized unit for having EAR of 8.5 and the size of 7.5 to 11.5 tons. Similarly, photovoltaic is taken care of, and then there's a combination. This is the manual and the simulated model, and there are 3 lines. The first one is the blue line, that is the first energy model I have created. The second one is the iterations, the orange one. So the first one is a manual model of buildings. These are the buildings, and this is in megawatt hour electricity consumption. So, and the third one is a simulated model, the red one. So the red one, so the main thing is I try to reduce this orange one, the third iteration and the simulated one, the gap. I want to calibrate the model, then I have taken up the 5% limit as per decided by the SRA. And this is how I was able to reduce this 3 iterations and simulation model gap up to 4.85%, so within my limit for RTU quota. And for Ajmer it was around 4.05. So once I achieve these tolerance limit, now I can say that my model is calibrated. This is how, when I run the simulation, the computer block as expected, which has IT building, IT department, computer department, lot of labs, so which has 167 megawatt hour of electricity consumption. The labs were generally, they don't have any HVAC thing, and they don't even run lights, so they have a very less EPIs. Now, as far as when I implement the EEMs, it is found that most of the they have a positive impact, but some of the EEMs like the wall and the shading device and the roof, at some buildings they are showing the negative results, which shows that there is no further scope of improvement in terms of building envelope design. But yes, the daylight, the EEM1, that is the daylight, that is the blue line, which is showing most of the improvement, that if daylight integration is there, so then LPD demand can be reduced, and up to 7.42%, if I clearly remember that, the average reduction is there. And definitely these two represents the mechanical component and the solar photovoltaic component. This is the detail that for computer block EM1, that was daylight, 5% reduction is there. The average was 7.42, and here you can see that the wall and the shading 0.23 and 0.79. So it clearly implies that the buildings are already optimized. Even the new buildings are come up with the same architectural principles that had been used by the architect in the old buildings, specifically in RTU quota. And then the combination, if I go for the centralized SVHE, which is giving the best result, that is 22.85% reduction, and converting all 3-star into 5-star HVAC units, then it is giving 11%. So definitely the mechanical component is on the higher side for achieving energy efficiency. But yes, the EPI is too low to make a generalized comment at this point of time, because if EPI is on the higher side, definitely the architectural component will be a lot higher in that case. Then as far as renewable is taken care of, then most of the buildings in RTU quota, the 5 buildings, they have already used, are already using the PV panels. So I just try to find out the old admin building where 73% of the requirement can be generated from this. Now the EM10 and EM11, they are the combined effect. The combined effect of architecture was found to be 14.85% for all the buildings, and it is maximum in case of say 19.46 in the examination. So more or less it is consistent, but in old admin it is too low because old admin is having accurate kind of structures, uh, walls and thick walls and skylights, everything is there. So that is one of the reason that the old admin is having such a low number. And then overall implementation, yes, around 39 to 40% can be easily achieved if mechanical and architectural interventions are taken into account. This is how the architectural, this is the cumulative effect of all the 6 for individual buildings. So more or less the mechanical part in this, I want to specify that 8A and 8B, out of these two, only one is considered. Now this is the methodology that I have adopted for survey. Thermal comfort survey is done. Data loggers were installed in 2 buildings, that is block D and computer department. And this is how the area is there, and this is the summary chart where installation is done. But unfortunately 2 data loggers, they stop functioning, so still I have data for 4 rooms at least. Now yes, this is the Indian model of thermal comfort, and this is the data I got from the 4 rooms, and these are the limits as per IMAC. And the bold temperatures are the areas at the time where the room was showing which are out of the comfort limit. So this is the temperature humidity chart. This is, here you can see the computer room AC is clearly showing that it has low temperatures. This is the computer room, this one. So this computer room, this one, this is on the lower side. It means the temperature is generally on the lower side than the labs which don't have air conditioning unit. So this helps me to find out the set point temperature in some of the rooms, and I was able to use that set point temperature into my simulation. So AC rooms have on an average around 25 to 26 degrees Celsius temperature when the building is in operable stage, and non-AC rooms generally have average temperature beyond the thermal comfort limits in the month of April, May, June, January and Feb. The result is consistent for the thermal comfort survey that I have done. This is the result of thermal comfort survey for block D and block this is for block D. I'm sorry, this is block D and this is computer department block. So for block D, you can say that yes, most of them this is for monsoon period, most of the people are in comfort, but in during the winter time, yes, almost 45%, 46% the people are saying that it is too cool. And in summer, yes, more than 52% people are saying that it's too hot. For the computer block, there is the variation is more or less similar, not skewed like in case of D block, because the computer block has EPS insulation is also integrated into the, so there is a less variation. This is the data logger data temperature humidity data that I derived for one of the building. This is the EM run chart. Here you can find out for individual building blocks. This is the percent reduction in EPI. Say in case of this administrative building for EM1, at that time energy consumption was around 170 odd, and then there is a reduction for every EEM. And these trends are more or less similar. These graphs are more or less similar in nature, which shows that the model's accuracy, which can be seen in model accuracy, that yes, the model are quite accurate. Now this is the EPI. This is an interesting slide that I want to say is the data was too vast, so I come up with 3 buildings and 4 type of rooms I have taken up. So for lecture area, for D block, the EPI was coming around 14.69. For computer, it was more than 2.5 times, and for academic building, they are more or less similar for ECE Ajmer. So it means the area that is having more tonnage of air conditioning, they are showing more EPI. In faculty room, the situation is reversed. in D block for teaching lecture room, there is no air conditioning unit, but for faculty room, there is a split AC is given to them. But in computer block, it has been found that the teachers are going to the labs, so they are staying less within the faculty room. So that is why the EPA for the faculty rooms is on the lower side compared to the D block. For academic and department building in ECA, it is less because there is less tonnage of air conditioning. For labs, yes, computer department as expected is almost 8 times than that of the D block. The D block doesn't have air conditioning units, and the naturally ventilated spaces of D block, RTU quota, and academic and department building of ECA, they are more or less similar. But if there is some mechanized component is involved within the you can say the energy consumption domain, then definitely there is a difference. And strategies and recommendations, after going through my study, then I found that there are 2 types of institutions. The first one is like institute which are lacking some metering, but they have some basic expertise person that can be an energy auditor. And there is another where energy auditor is there, but who have more knowledge related to software component, like in case of RTU quota. The first, in case of Bikaner and Ajmer, you can say the first one is there. So for first type of institutions which are lacking some metering but have a basic expertise level, then they can go for the first part, that is the manual approach, and they can go for the manual approach and they can develop the model. And then further, if possible, then investment grade energy audit may be taken up to identify or the walkthrough energy audit, just to find out the basic areas where energy can be saved. It may be as simple as changing of bulbs with more efficient bulbs. Then the second type of institutions, with those having more knowledgeable person in terms of simulation skills, then the second then the simulation approach can be taken up, and or the hybrid approach with combination of manual and simulation, which the hybrid is approach I have taken up. So it is possible to do to create a hybrid model which is good enough to represent the actual scenario, so it can be taken care of. And this is again I have strategies like identification, hiring of a person. Then so these are the mechanism through which this energy efficiency can be taken up, like identifying, hiring of a person, having knowledge of building performance, and energy audit of various buildings, which is given in these sections. So investment grade energy audit can be the creation of model and identification of energy efficiency measures. So depending upon whatever I have done, they can be implemented for their respective institutions. The choice and application of EM shall depends upon parameter like availability of resources, budgetary provisions, life cycle cost analysis. Again, this is important thing because in my consideration, I have taken up reduction in EPI as one of the important parameter. Since EPI is low, so I cannot go for any kind of payback analysis and all this, because if EPI is less than 40, then any kind of intervention, architectural interventions, it is almost next to impossible to show any analysis which payback within 20 years domain. So for this is for the institutions to go to choose. But yes, as I already said that the universities can act as role model. So if we want to create our universities best possible, so at the very beginning stage when we are designing our building, these things has to be taken care of. Now, as far as the results of EM are considered, some of the strategies depending upon my results, I have formulated that the daylight integration, there is a reduction of 7.42%. So daylight integration can be incorporated since we have, it is found that the window to wall ratio of my buildings are within the range of 20 to 25%, which allow a lot of daylight come into the building. So daylight integration can be used where the light near to the windows, they can have a sensor, they can dim the light so that a lot of energy can be saved. Yes, lighting power density, maximum energy lighting power density shows the maximum reduction, that is 9.4%. Then fenestration, it has been recommended that the windows that are located in old buildings, they are broken, so they can, to reduce infiltration, they can go for DGU if air conditioning room is there. If there is no air conditioning room, then there is no need for DGU. See, SGU is more than enough. For insulation, roof and shading, they have less than 1.06% in all the cases, so which signifies that the good construction practices are involved. And 2 degree Fahrenheit reduction is able to reduce in thermostat temperature, can reduce up to 3.626% reduction, so that is good. For as far as ER, energy efficiency ratio of air conditioning device is considered, 11.38%, so this has already been discussed. The combined effect is 14.85%, so it's a matter of choice here that if go for a best possible strategy, that is daylight integration, or going for the second, going for the lighting power density. So lighting power density and daylight integration are the most preferred one. Overall 6 measures are going for 14.85, so it may be a matter of choice whether to go or not. Now, in overall conclusion, the majority of proposed EM have given energy saving potential in future case scenario where air conditioning load is increased. So in scenario where the air conditioning load is increased, say up to 25%, then definitely the architectural EMs, they will show a great promise. So in the present case scenario, it is available to implement that most effective EM so as to decrease the energy consumption instantly. Payback period in case of higher education institution seems high, but university can act as a role model. And establishing a grid connected solar system can become a mandatory provision as stated earlier. Nowadays, after 2018, most of the institute, they are coming up with grid connected solar systems. So that is a good intervention that is happening in India. And there are 2 types of measures, RESCOs and SEPEX, through which it can be done. So finally, I conclude by saying that to make the sustainable relevant in today's context, energy efficiency can act as major approach to attain sustainability. Energy efficiency of institutes in India is not properly addressed, but comprehensive management plan need to be done. So for that, strategy is being provided. EPI of study case buildings found to be low in comparison to the international standard, and EPI of rating systems, which are given by rating systems. National level institutes have more EPI than the state level institutes. The energy statistics in terms of EPI of institutes are varying to be 15 to 35 kilowatt hour per square meter per annum, which is quite less than, fall below the benchmark given by the GRIHA. The methodology that is given in the study can act as a catalyst for creating database for institutions throughout in India, which are lacking in some metering. And most probably for the first time, this type of detailed study has been done related to the energy efficiency model creation and a methodology to investigate EPI of and other parameters of 12 buildings located in 2 different institutes in a similar climatic condition. The research establishes a unique integration decision-making methodology for creating energy consumption models for integrating manual and simulation models, which can be used for university that is lacking in some metering, and which is demonstrated through RTU quota and ECA HBA. There are, since all study has to culminate, but there is a future scope always. So these are the scope. Development of energy models can be done for other higher education institutions. Implementation of developed methodology for various institutions. Extensive studies can be done for specific universities, like a single university, and extensive study can be done. Creation of national-wide database for energy efficiency. So once this for different universities, if this is done, then GIS platform can be used, or some other IT platform can be used to create a database. Visual comfort and combination of visual comfort and thermal comfort can be carried out for institutional buildings. And this is again for policymakers, for IT sectors. So these are the these are the different paths they can use. For university, they can go for path 1. If auditor is there, for part 2. This is already discussed. For policy makers, yes. So this is the summarization what I have discussed earlier. These are the publications and the presentations carried out. And if madam permits me, then I can reply the comments also, ma'am.
I don't think so. I've gone through it unless and until somebody else is interested to go through the comments. But I have seen all those replies. Uh,
Yes, ma'am.
so
I think, Professor
would you
Inya,
like to go through? Yes.
nobody else to ask these comments. If you are satisfied, then you can ask some queries related to his presentation.
Yes, please.
Uh-huh.
Well, let me, Architect Sunil Sharma, and now going to be Dr. Sunil Sharma. First of all, bring the smile on your face and let me congratulate you for the extensive work you have done under the guidance of your supervisors, Dr. Ashwani Kumar and Dr. Nand Kumar. Uh, and I really liked the fact that the topic itself really enthused me, that people who are familiar with the university setup, they know, very well know, that in the institutional setup in India, there is hardly any focus on energy efficiency. And as you rightly mentioned, educational institutions can play a very, very large, they have a large influence area, particularly in terms of SDGs. And I'm not talking just in terms of energy efficiency per se, but overall, you pick up any SDGs, and universities are the best areas to be the starting point and the game changer for the larger community and society. Uh, some of the questions I think which I had, you have both the minor and the major ones. You have already replied in great details, and I'm totally satisfied with the results. Few basic questions, if you are if you can take up. May I?
Yes, ma'am.
बहुत छोटे छोटे सिंपल से क्वेश्चंस हैं. अगर ये स्टडी इंजीनियर करता तो क्या करता? I just want to see. I mean, these are sort of. Um, uh, I mean,
Yes.
very simple. मतलब मैं आपको बहुत research style level का question नहीं पूछ रही हूँ. But if the same study would have been taken up by an engineer, because a lot of people from the engineering field are also into
Yes.
the energy efficiency domain area, what will be the key difference?
Ma'am, the key difference will be they will not they could have taken up 3, 4, 5 buildings which have through which they can extract data.
As an architect,
So as an kindly
कुमार जी आप अपना माइक्रोफोन ऑफ कर दिए तो
kindly
नहीं होगा.
आप सब लोग there is a discussion going on, so kindly switch off that there is a echo coming. Yes. Ma'am, what I feel is that the engineer would have done the similar kind of work, but yes, the emphasis on architectural parameters will be on the lesser side, because taking up drawings, doing up surveys, so that is itself a big task. So taking up, I please, echo is coming, so yes. So the thing is that definitely they could have done the similar kind of work, but yes, as far as architectural parameters are considered, they might have not go deep into it, and for taking up decisions related to the tolerance value of EMs, they might have not they might have gone different ways. So methodology creation was the most important thing, because my software was little bit limited in terms of architectural skill. Design builder could have been better choice, but due to due to time constraints, so they do, so say they might have been taken up. So I am not saying that I could have taken up better software. Generally, engineers go for softwares like DOE2 and eQUEST, and architects go for eQUEST and design builder. So as far as the common ground is considered, eQUEST becomes the common ground. So definitely, as far as architecture is considered, my designing of methodology was the most important thing, which might have been overlooked by engineers.
Good. I'm happy to hear that you have a clarity of. Kumarji, please.
Yes, yes, Professor Ina. Yes.
Yes, सुनील जी एक और क्वेश्चन बताइए. I completely understand you have done the study in very detailed form and considering all kinds of constraints which are there in the university setup. My question is, why didn't you highlight the difference between because you being an architect, why I asked the earlier question, why didn't you highlight in some of the recommendations that what was different in the old building design versus the new one?
I have not covered, but yes, I have written in my presentation that I have written in my presentation in one of the strategy that yes, the old buildings, they are showing promise in they are good enough because I am not getting too much of energy efficiency reduction. So whatever the old buildings, they have architectural features, they can be incorporated in the buildings for future creation. So they should incorporate some of the strategies. So that is
So this should have, I know you have covered. What I'm saying is you have not highlighted enough. This is something very good. And what happens is administration often overlooks कि अच्छा ये old style हो गया. They don't want to copy the style, thinking the notion, considering the notion कि ये efficient नहीं है. Jabki from efficiency perspective, you must have realized that old buildings are really well, except for maybe the visual comfort part and maybe daylight integration in some parts. With limitations, not
yes,
necessarily. तो ये आपकी स्टडी में भी आया, लेकिन आपको उतने अच्छे से कल आउट, you have not hit it rightly in the sense that it is all there. I know it is there. लेकिन that was the responsibility of an architect, that you should have brought it out enough with enough emphasis that किसी को अगर उसमें से निकालना हो तो उसको पूरा देखना नहीं पड़ेगा. He can cut it out. Okay, this is one of the very good findings.
Yes, ma'am. Yes.
Yes. Then again, one very basic question: which segment would you like to put your thesis in? Exploratory research, descriptive, or explanatory?
It's an exploratory research. I will put it into it because lot of things need to be explored at initial level. That are not we are not architects are not accustomed with. So initially that exploratory I would put it like validation. As far as is considered, even the softwares, we cannot say that the softwares are giving up the right data. The softwares are good enough for suggesting which option is more suitable than the other. So I would say yes, it could have been more validatory if I have used some electronic instruments like some mechanical guy or something. So I would say it's an exploratory more, yes, which is relevant in today's context. Yes.
Yeah. I think what you have adopted is perfectly suitable for from implementation perspective. In the methodology also which you have proposed is extremely good. And my last question is, if given just 1 minute to you, what will you say as one of the most important key takeaway from this study?
The most important key thing is the combination of methodology, that is the 3-part strategy, and through that 3-part strategy, whatever be the university, whatever be the institute at level, at very basic level, no infrastructure or have infrastructure, or so they can be their data can be taken, extracted, and portal can be made so that all the institutions, we have the data of all the institutions. So the main thing is all the institutions which have different level of expertise. They can come up with their models. We can extract the data, so we can have a large database at national level. So recommendations and generalization, so it will help in creating uh, in evolving the codes that we have. That is what I feel, because the codes need to get revised, and they can revised when the large pool of buildings are taken into consideration, and that is only possible when the institutes are self sufficient in their own domain. If they don't have resources, it doesn't mean, if they don't have auditors, it doesn't mean that they cannot create database for them. So it is important that yes, uh, various checks are there. If they get some if a institution which don't have auditors knowing simulation, if in the future if they have ready database, they can convert the manual model into simulation, and subsequently the all the data can be updated. So this will help in actually updating the codes that is pertaining to the institutions. So this is what I feel. Yes, ma'am. Thank you. Yes.
And any comment on the behavioral aspects, because you must have seen while taking all the data set from which you really did very well, good job, detailed manual data collection. On the behavioral aspects, that as long, and it's a very typical trait of Indian society, that as long as it doesn't pinches me, which means that if I'm not paying the electricity bill, your ACs will be on, your fans will be on, even if I'm not there in the space. And this is very, very prominent, at least in the all kinds of public buildings, including the university system. That's my personal observation. Any comments on that?
Ma'am, the comment is if we have some kind of display system, energy room kind of a thing in every institute, in which if this methodology is there, and if the data is shown to people that this building is having this kind of consumption, then the people will be made to say, so they have to create some kind of policy so as to reduce the energy consumption of that building. In the more refined version, even the different rooms can be taken care of. So this is the, you can say, the first step in the Indian context, which can help to highlight which, and this doesn't even need a sophisticated high-tech system where you have everything submetering and everything is there. This method doesn't need that. So for the Indian context, for the institutions which are struggling to even get to get run itself, they don't have money. Some of the institutions, they don't have the budget to follow that. So just by implementing it, one good auditor, if they have, then it's good. So it will help us to create an ecosystem with the bare minimum of resources. The data will be created, and that data can be projected into that room. In that room, anybody can go and see, okay, this is what for the last 1 month. For every month, the data can be updated, or for every quarterly, the data can be updated. So that can create a sense of numbers within the minds, because people are not educated about the numbers. Okay, 14 megawatt, 10 megawatt, they hardly know this. So once they get accustomed to it, we can make say this is good, bad, and this. So this will create a some kind of ecosystem that will help. Yes.
Good. So that's all from my side. And if anybody, the floor is now open. If anybody, any questions from the audience?
Please, audience, have any doubts, any questions, any queries? Hello, audience. Please ask any
Sir, I
questions.
think everybody is happy.
Okay. Thank you, Professor Hina, for giving very valuable suggestions. Really, can we declare Architect Sunil Sharma, Doctor, with your permission?
Yes, absolutely. A big round of applause for Dr. Sunil
Yeah.
Sharma.
Thank you. Thank you.
Thank you, Dr. Hina. Thank you so much. Really, we are grateful to you. Really, you have done very great job. And today, Sunil Sharma is from architect Sunil Sharma is converted to Dr. Sunil Sharma. Really, this is a great day for Dr. Sunil Sharma and for your valuable suggestion and giving more than 1.5 hours. This is really very good. And now Sunil Sharma can take up this work further. He can discuss with the universities how to implement this energy efficiency strategies at the university level or state level. So this is a very good topic, and he has done the very current studies, I think. Any other thing?
सतीश सर आप कुछ बोलना चाहते हैं?
Yeah, thanks. No, it's wonderful. I'm happy. I know that there's one more doctor from our department. Thanks very much, Professor Hina. We look forward to many more associations in future. And am I audible?
Yes, sir.
Hello. Yeah. So thank you very much, Professor Hina. And we look forward to your presence in our department in near future sometime.
Absolutely, my pleasure. I am also looking forward to have so-called normal times and when I can further visit the institute. That's one of my
Thank you.
favorite.
Thank you once again.
Thank you, ma'am.
Thank you so much.
Thanks, ma'am.
Yes.
Thank you, ma'am.
Thank you.
Thank you, Professor Hina, on the behalf of the Department of Architecture.
Yeah.
Okay, most welcome.
Thank you.
Thank you, ma'am.
And I would also like to congratulate Dr. Nand Kumar ji for the new change I was not aware of.
Yeah. His treat is due. Means we also need treat.
When really,
Yeah, treat you.
very soon we'll call you at Jaipur. That time definitely will give you a good treat.
और डॉक्टर सुनील शर्मा आपने भी चाय पीनी है.
Yes, yes, definitely. Yes.
Okay, thank you so much.
Thank you, Professor Hina.
Thank you, Dr. Ashwani. Thank you, Dr. Nand
Thanks,
Kumar,
ma'am.
Satish ji.
Ah,
Yes.
yes.
Thanks, ma'am.
Recording, sir. Recording बंद कर.
हाँ कर दे.